Okay, so in the last video, we were, we went over conversion factors, and I hope you watched the video. If you didn't understand it, and if you still have questions, you can email me or come speak to me on Tuesday. If you come in after 11:30, I can help you. So today we're going to do, right now we're going to do scale factors. Okay, so when you're looking at a map or a photograph, most of the time the image has been scaled down. Okay, and hopefully this makes sense. Like, think about Canada. Canada is really, really big. If we had to map the actual size of Canada, it would have to fit in all of Canada, but instead we can just hold a map of Canada in our arms or in our hands, and we call this a reduction. Okay, so to make smaller. When you look at an enlargement of something, on the other hand, then it's been made larger. Okay, so it's been scaled up or enlarged. Okay, so for very small things we enlarge them, and very big things we reduce them. Okay, and so you'll have done this in science. When you look at things under the microscope enlarges things for you. And so here we have an example. A map has a scale ratio of 1 to 50,000. So 1 to 50,000. And we write ratios with a colon. Okay, so you'll always see a ratio written with a colon. And this 1 to 50,000 ratio means that every 1 unit on the map is 50,000 units across the land. Okay, so if this was given in units of centimeter, every centimeter on the map is 50,000 centimeters in real life. And to practice our conversions, let's do this. Let's make 50,000 centimeters into kilometers. Okay, and we'll put this over centimeters. And check out how many centimeters are there in a kilometer. So if there's 100 centimeters in a meter, and just give me 1 second. Okay, sorry about that. So if there are 100 centimeters per meter and 1,000 meters per kilometer, then down here we would put 100 times 1,000. Okay, and then we would end up with 50,000 divided by, that ends up being 100,000, and we would end up with 0.5 kilometers. So if you're looking at this map and you wanted to go from here to here, say that's about 1 centimeter, you would actually have to walk or drive 0.5 kilometers. Okay, so that's why we use scale factors. It just makes it a little bit easier to see a bigger area in a smaller space. So we can express scales in 2 ways. We can either use the ratio or scale factor. Okay, and a ratio would be like a 1 to 20. Okay, remember that the ratio uses that colon, and so the image, so the photograph or the map, is a 1 to 20 for the real life. Okay, so in this case, the 1 to 50,000, the 1 is the map and the 50,000 is the city. Okay, so the city itself, and when you're on the ground, that's the real life distance. Or we can use scale factor. And scale factor, put as SF, equals real life over image. So for this, if we use our 1 to 20 again, so our real life is 20 over 1. 20 divided by 1 is 20. So we have a scale factor of 20 or a ratio of 1 to 20. Okay, and please note this, there are no units for either ratios or scale factors. And if you look back here, we said the map has a scale ratio of 1 to 50,000. We don't know what that is yet. You have to be told, and this will be in the legend of a map, or here we told you 1 centimeter is really 50,000 centimeters in real life. So let's try an example. Below is a picture of the Eiffel Tower in France. The actual height of the tower is 324 meters. Let's find the scale of this photo. So let's look at real life. We'll write down what we know. Equals 324 meters. Okay, so real life is 324 meters. Now get out a ruler and measure the height of this picture. Okay, so measure this height with your ruler. Don't just wait for me to write it down. It will help you to measure it yourself. Okay, the more you do things yourself, the more pathways your brain makes, and then it helps you remember things. So measure the photo height with a ruler. Okay, and especially for this first unit, you should always have a ruler on you. We're going to be using it a lot. And if you measure the photo, and I hope you really measured it, it's 8 centimeters. Okay, so here's our real life, our image. In this case, our image is a photo. We have 8.0 centimeters. Okay, so here we have this in centimeters and this is in meters. We need them to be the same. Okay, they need to be in the same unit. So let's convert this 324 meters into centimeters. So 324 meters. We'll put meters on the bottom. How many centimeters are in a meter? Remember that there are 1,000 centimeters in a meter. So we end up with 324,000 centimeters. Okay, so 324,000 centimeters. And remember that we did that to get them in the same, I'm sorry, there's not 1,000 centimeters in a meter, is there? There is 100 centimeters. Okay, so 100 centimeters in a meter at 324,000 centimeters. And now we will do scale factor. Okay, so let's try scale factor. So remember, if we look back here, scale factor is real life over image. Okay, so let's do scale factor equals real life over image. So real life, we have here 324,000 centimeters over image 8.0 centimeters. My centimeters cancel out, which is good because I don't want any units. And I have a scale factor of 4,050. So it's quite a big scale factor. You can also use a ratio, and so the ratio will be what? Write a ratio, be 1 to 4,500. Okay, same thing, use it there. So let's try another one. Below is a photo of a statue. The scale of the photo is 1 to 46. Find the actual height of the statue in meters. Okay, so the scale is 1 to 46. And remember, if we go back here, back to our first page, the ratio is image to real life. Okay, so we have image to real life. Okay, so measure your photo again with your ruler. Measure how high this is. And I got 5.4 centimeters. Okay, and remember that this is our ratio, and our scale factor would equal 46. Okay? So, in real life, will the statue be bigger or smaller than the picture? Hopefully you answered that. In real life, the statue is bigger than the photo. Okay, so if we use scale factor, we can go, so scale factor, okay, so if you look back here, scale factor equals real life over image. So let's rearrange this to get, so scale factor equals real over image. To get real all by itself, we use our algebra. We'll multiply both sides by image. So real life equals scale factor times image. And remember that we said our scale factor was 46. We wrote that up here. So we have 46. And we have our image as 5.4 centimeters. And that gives us 248.4 centimeters. Now let's look and see what they asked us in the question. Find the actual height of the statue in meters. So right now we have centimeters, so we have to convert our centimeters to meters. So we have 248.4 centimeters times, put centimeters on the bottom. We want 1 meter because we want to find how many per meter. And remember, there are 100 centimeters per meter. So we'll end up getting 2.484 meters. So in real life, the statue is 2.484 meters. Okay. Let's do another example. So a photograph of a bear has a scale ratio of 20. Express the scale as a ratio. So scale factor equals, remember, real over image equals 20 over 1. So as a ratio, this will be a 1 to 20 ratio, 1 being the photo or the image, and then 20 being the real life. Okay. If the actual height of the bear is 2 meters, how tall is the bear in the photograph? So again, if we look up at this equation here, we want to know image. So we get image by itself. So image equals, and this is just straight up algebra, real divided by scale factor. So then we will do real life. So in real life, the bear is 2 meters. Our scale factor is 20. So 2 divided by 20, and we get 0.1 meters. So the bear in the photo is only 0.1 meters, but the bear in real life is 2 meters. And then for lowest terms, a scale ratio is usually expressed in lowest terms. To get into lowest terms, divide both numbers in the ratio by the smaller number to get the smaller, divide both numbers in the ratio by the smaller number. So if we look at 2 to 3, okay, and what we can do is 2 to 3, and let's see if this is in lowest terms. Okay, if you already think it is, that's fine. If you think it's not, we'll prove it. So we'll divide both by 2 because 2 is the smallest, And then we end up with a 1, because 2 divided by 2 is 1, to 3 over 2 ratio. Or we can say a 1 to 1.5 ratio. And that's our very, very lowest term. And you can see that it's lowest because it's lower than 2 to 3. Let's try this. Express the ratio 0.4 to 20,000 in lowest terms. So, just like we did before, we are going to divide both numbers by the smallest number. Okay, and this is a ratio sign. Sometimes my pen drags it along. So we'll divide both by 0.4. Okay, so this would give me 1 to 50,000. And that's my lowest term. So when you're looking at a ratio, we always want to have a 1 in here. Okay, and to get a 1 as the first term, you just divide by the smaller number, and then you'll end up with a 1. So now I'm going to get you to do questions in the text. Again, I'm going to scan this page in with the answers, so you can work on those, and there'll probably be one more video, and then on Tuesday there'll be a new video for you. All right?